This is the Amp Hour Podcast, released January 31st, 2021, episode 528. New year, new gear.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
I've still got it in 2021. Still got the intro, nailed it down pat.
Still got that.
Still got it.
Like Mojo. You got it, yeah. How was your holiday?
Excellent. Thank you very much.
You've been gone for 3 weeks. I don't know if you know this.
I've been gone for, quite a few weeks.
Yeah.
And then you forgot I was back. And you already had a couple of shows already pre-canned. So, we ended up skipping a week when I would have normally been back.
Well, another week of relaxation in the EEV blog world. So what have you been doing with that week that's back now? Now you're back. So what now?
Just trying to catch up with crap,
Yeah.
Business crap takes half my time.
Business crap does take a lot of time, for sure.
Yeah, been trying, because I, for those who don't know, I do run a packing and shipping business as well as a, and a forum business, like advertising, I've got...
If this is your first show, you probably don't know this. If it's not your first show, you've probably heard.
We've got new people joining all the time. Come on, our show's growing, isn't it? I haven't looked at the stats. Where are our stats at? How many viewers we got?
No viewers, but we're pretty flat.
Listeners.
We're pretty flat. So if people are listening, you can tell your friends, tell your coworkers. I think the other thing is people are not like driving in cars and going on walks and.
So what you're saying is that we don't have much chance of that, $10 million exclusive Spotify deal.
That was $100 million for like.
I know,
Rogan,
but we're like I'm just estimating we're an order of
Got
magnitude lower. So
I wouldn't hold your breath.
Oh, that'd be each. Like,
right, of course, yeah.
Right, because it doesn't buy much these days. Because
Yeah.
Anyway.
Cool. Well, I have been upgrading so you sell stuff and I've been buying stuff, so you'd see who's making money, who's spending money. But they say you got to spend money to make money, so apparently I'm going to make money at some point.
Oh, you're going to be rolling it in if you buy enough stuff.
Point.
Have you seen the test equipment syndrome videos that I posted on Twitter?
No.
Oh, the test equipment acquisition syndrome videos. Well, I'll have to link them in. I forget who does them. He's a YouTuber.
TEAS, right? Yeah.
TEAS, test equipment acquisition syndrome. Yep, if you search my Twitters for that, you'll probably find it.
Okay.
Test equipment acquisition syndrome. I'll find it. It's great. Anyway, I forget who does it. Sorry.
It's a sickness. I think many people here can probably relate. So
yes. Anyway, they're very well done videos. There's 2 parts.
What's your most recent piece of gear?
Oh, my most recent piece of gear. I don't buy much because companies send them to me.
Yeah. It could be acquired or bought,
Oh, yes. Acquired would be the high voltage probe, the new Mixig high voltage probe. I'm thinking about going for a a lot of don't know this. I've been selling my high voltage probe for quite a few years, my HVP 70, and which is a great probe. But the only issue is with it, it's very expensive.
Yeah.
So I actually contacted Mixig, who I'm reselling their current probe for. Their current probe is really good and it's reasonably priced. Probably the best bang per buck on the market. Anyway, so I contacted them and said, "Hey, look, I see you make these other other high voltage probes, but you don't have one that's 10-to-1 and 100-to-1 ratio. They only had the higher ones, for higher voltage systems. And can you actually make one specifically to match the HVP 70 specs with ×1 ×10 to match all the other specs?" And they went, "Oh, yeah, probably." So, 7 months later, they came back to me and said, Yep, we've done it. Here it is. And then they started selling it, of course.
Yeah.
And because it's not exclusive to me, so you can go out and buy it now. And so I'm thinking about reselling that one. But I've been testing it and I've had a little issue with it. So I'm waiting for them to get back to me on that. So, yep. Yeah. Anyway, it's a common mode rejection ratio. I tested its common mode rejection ratio performance versus the HVP 70. And for some reason, it doesn't quite meet spec. So I'm wondering, look, have I goofed it? Because you always second guess yourself. you know,
totally. Yep.
For like measurements like that you don't do all the time. You know, it's not like
exactly.
My day job is doing CMRR measurements on high voltage probes, you know.
Right.
So yeah, I thought, you know, so I sent them a video.
What actually about the probe itself helps with the CMRR? Is it like the insulation or what, or like channel isolation, or what is it?
It's the symmetry in the design, in the internal design, the balance of the internal differential amplifier. So if you look at your current, like if you look at your traditional, like, you know, 2 op amp differential amplifier thing, you know how you can make a differential amp with, like, you know, 2 op amps, and it's a classic building block circuit. And if you unmatch the resistors, like if you use 1% tolerance resistors on there, right, which sounds pretty, you know, tight, right?
Yeah,
They're 1% tolerant. Like, I don't care about the gain much. Well, yeah, okay. You may not have an issue with the gain, but you will have an issue with the common mode rejection ratio, because when those resistors differ, when the divider ratios differ in the inputs, right, to your differential amplifier, I'm not explaining this right, but anyway, when they differ, if they're not matched, that can actually contribute to higher common mode or lower common mode rejection ratio. So that can make it worse, i.e. So it's matching. So that's why, you know, you open up these high voltage probes, and I've done a teardown, they've got like lots of little trimmer, you know, caps and other and trimmer resistors and things in them, you know, because somebody was.
So they do that like at the factory.
They do that at the factory. Yeah, that's why they'll have, you know, holes in the can. You know, they'll have trimmer holes in the can. So you assemble it all, and then you test it, and then somebody gets in there with a non-conductive screwdriver and tweak with their tongue at the right angle, tweaks the knobs. So yeah, to get decent performance. So it's probably something to do with that, would be my guess. So
got it.
Yeah.
Huh,
that's
cool. Okay.
That's the usual thing anyway. So
yeah.
Anyway, I've got the I've got the link to the test equipment syndrome, so I'll whack that in.
Okay. All right.
There you go.
Cool. Great. I've been doing some battery testing, and so I didn't have like an active load that I hadn't built. So like I didn't feel comfortable doing like multiple amps or anything like that. So
it's just been like you've just had those low power do-it-yourself ones?
That's right, yeah. And so this one's a Siglent 1020XE.
Right. Is that a new model? I haven't been keeping up with.
I don't know what it is. Yeah.
Active loads.
But it's super helpful. Like I kind of wish I would have had one soon. Like I always kind of, you know, I have a source meter on my bench. And so like that's great. I feel very lucky to have that, honestly. That was from my
because they're a high-end bit of kit, right? You
right, exactly. And those are meant for precision, right? And like, and you can do them in, 4-quadrant. You can like, you use them as a load, whatever. But they're just kind of awkward as a load. And like the Siglent thing, it really just any active load. It's just nice. It's just a dumb programmable resistor.
It just does its job. Yeah, it doesn't do anything else. It's just a variable resistor load, basically, or an active load.
Yeah, sort of. It does do one other thing that I did find actually very useful, which was on constant current. It actually will. So I was doing like just a battery test on a lithium ion that I had sourced from China. I just wanted to verify specs, and it's literally like a one button. Hey, I want this to go test it down to like 3 volts, and then tell me how long it lasts for at 800 milliamps or whatever.
So you just set the cutoff voltage you want, and it'll discharge and then stop. I know they're great. Yeah. They're worth their weight in gold.
Yeah, and it really wasn't. I think it was like $300-400 or something like that. It was pretty cheap in the States, and so yeah, that's been a really beneficial thing, and I've been using that for troubleshooting too. You know, like I had some power supplies that I thought were like oscillating or something like that, and it ended up being a totally different problem, and I was able to verify it just by throwing this active load on there and just be like, nope, half an amp, 1 amp. 1.5 amps, like this thing, and it's going through, wires too. So it's got a bunch of inductance on it too. And it's just, it's rock solid. So really, really, really worth it. So wish I would have gotten one a lot sooner, I think.
Oh yeah, they're great. Well worth having. I mean, as we said, you can do it yourself, right? One of my most popular videos ever is a do-it-yourself load. Right? Countless people have done variations on my do-it-yourself active load. There's so many open source ones.
I have that on Contextual Electronics as well. Yeah. I think it's actually a great first project for people that are like looking to do a first project too. I think it's totally. Like, if you're looking to get into analog electronics, you can chase all the op amp problems. You can, you can build something that's actually useful on your bench later. Like, I mean, I felt comfortable, I think, cranking an amp through that thing, and it was great for that.
No, it's fine. But the only issue is that it doesn't have all that nicety stuff like, active cutoff. It doesn't have like a keypad and a graph, and you can't set the active modes, and you probably can't do constant resistance mode. You can't do constant power mode and stuff like that, right? Which you need active smart circuitry to measure and compensate. And in that case, I've killed power supplies. As part of my review process for power supplies, I put an active load on it, and I put it in constant resistance mode. And then because the load actually dynamically responds, fairly quickly to changes in the source voltage to give that constant resistance load, it actually makes power supplies hiccup. And I've actually killed output pass transistors in commercial power supplies using this active load. So it's like a torture test thing.
What about it makes it hiccup though? What do you think is making that happen?
Well, the power supply outputs a voltage, and then the power supply responds by changing its load to try to simulate a constant resistance load, but it's not a constant resistor, it's an active element. So it's got to continuously, it's got that feedback loop. So you've got the feedback loop of the power supply trying to compensate for the feedback loop happening in the load. And if they get out of whack and your power supply is not robust enough, boom, you can pop your output transistors or do something else, So it's fun. I love active loads. Active loads are just I've got two of them here. And sometimes I've used two at once. They're worth.
What is I think that's the other thing that I wonder about is like the power envelope, and like this thing's relatively beefy. I think it can do like maybe 200 volts, maybe 10 amps at like the extremes, not both at the same time. I think it's like 150 watt total.
Right. Yes, you can get high voltage ones and low current, and low voltage high current ones and high voltage low current ones, and so it's a bit of a trade-off. Most manufacturers will make different models. Like any serious manufacturer of these, they'll make 5 different models catering different power and voltage and current ranges. So you've got to sort of pick like a generic kind of one that suit your stuff.
Yeah, right.
And then, but often I've gone, oh God, I wish it went to 150 volts, and then like, but then you can't have everything. You can't have one that does it all. So often, in like a serious lab, if you're doing power supply, a lot of power supply stuff, you'll have multiple active loads with different ranges. Yeah, very cool.
Yeah. Or you could rent them. You could rent them too.
Oh yeah, you could rent it, of course. Is that kid of the week? Is that kid of the week?
No, actually, the next thing is. So I'm actually much more excited about the second thing.
Oh, okay, right.
It's very good. Dave, very exciting here. Want to guess what I got?
What can possibly be more exciting than an active load?
I got a soldering iron.
Yay!
I know.
Which one? Soldering
I have moved up.
Exciting.
You've moved up in the world.
What did you get?
Yeah.
What did you get?
I have a Thermaltronics. It is a TMT 2000S. So not all the way up, but up. So this is very different for me.
Nobody gets excited about a Thermaltronics. People get excited about JBCs and
exactly.
and other brand Thermaltronic. Like I've never used one of those. Like I've never used that brand because I don't even think do they even sell them here? Couldn't tell you.
I don't know.
Where are they made?
They're made in the U.S., or I don't know if they're made in the U.S., but they're distributed out of the U.S.
Right.
They're former Metcal folks, though. And so they make...
Oh, okay. It's a spin-off, is it?
Yeah.
So can you send me a link? Send me a link to the one you've got.
Oh, sure.
Send me a link to the model. Let's have a look.
Yeah, and they started distributing through... I heard about it through the consulting forum, and they used to sell in DigiKey, but now they distribute through Amazon, so like extra easy.
Okay. Oh, yeah, you're an Amazon man. You're like...
totally.
If it's on Amazon, you'll simply buy it because it's on Amazon,
right? Unfortunately, yes. Yeah. But all the tips are also Metcal. They can also switch over and use. Oh,
that is a total rip-off of the Metcals.
Oh, wow. Yeah. So it's just like a lower cost version.
Right.
And it's like the lower frequency.
Yeah, well, I thought Metcal had those locked up in the patents. I thought they were.
I think it expired. Yeah.
Oh, that's why they spun off.
Yeah.
Oh, okay, right.
Yeah.
They've probably been working there for 20 years and went, guys, it's expiring in 6 months. Let's make our own company.
Let's go start a company.
Yeah. That's smart. Yep.
Yeah.
Wow.
It's been great. So I've never used like cartridge tips. Have you? Have you ever used those? the Metcals or JBC or anything?
Oh
like that?
yeah. No, of course.
Okay.
All of my irons have cartridge chips now. Well, I still have my old Heikos that are the old.
Got it. Yeah.
The old tip, but yeah, all my new ones are cartridge. Yep. And you just leave them in there. You leave them in the back of the tool stand, and then you just take them out as you need them and change them all the time. Yeah, it's great.
Yep.
Yeah.
So I think my soldering gear has always been kind of subpar. I mean, I've gotten along well enough, but this is like I think that's the thing for me is it's just like such a step up because I had been using such kind of low quality stuff, and it was starting to affect some of my solder joints and things like that, and I was just getting really frustrated.
Yep.
And it's just like I'm using it every day, and so it's
wow.
It's been great.
Okay.
And, there's a wide variety of tips and stuff.
Yeah, $230. Wow, that blows Metcal out of the water. And for people who don't know, it uses this one works at 470 kilohertz. I can't remember the frequency that. I think Metcal work at a couple of megahertz.
13.56. So that's the
13 kilohertz. Oh, I thought it was much higher than that.
No, sorry, 13 megahertz. 13.
Oh, I thought so. Yeah, I thought it was in the megahertz range. Yeah.
Yeah, it is. Yeah.
Right.
Yeah.
Yes, and that's how they use it. And of course, the Metcal fanboys, they're like the Tesla fanboys. Don't diss the Metcal. So they will, Don't go into a room full of Metcal fanboys wearing a Weller t-shirt or a JBC t-shirt. You won't come out alive.
I've heard people talk about them before, and then usually here's what my thing would be: if I'd read online or I'd hear someone talk about they love their Metcal, they love their JBC. I'd go to the site, be like, oh, $1,000, okay, and I just turn it back off. It's just that's not me. That's
no, that's right.
And this is kind of that in between where this is still expensive, right? And you can get some good low end irons for $100 or so.
Oh, right? You can get good low end irons for a couple of $100, and then you can buy a desoldering station, and then you can buy surface mount tweezers, and you can buy a second one because you need 2 soldering irons. By the way, one is not enough. It's like owning a multimeter. You can't just have one multimeter, right? You've got to have 2. Right. Likewise, you've got to have 2 soldering irons so that you can flip parts off. You can just get an iron on either end of a part and just go boop, pop it off.
Well, if you have tweezers, that also
if you had SMD tweezers, that works different.
Yeah,
that's solves that problem.
And I've been looking at those too, but it's like one of those things where I just have to be like, okay, Chris, just give it a couple months,
right.
Don't go too crazy.
I still don't have one. Weller have been saying they'll send. Sorry, not Weller. Pace have been saying they'll send me one for a year. They've got some new model that came out, and anyway, hasn't turned up yet.
Yeah.
But
so what's interesting about these things is that they're basically like RF amplifiers internally. Yes. And like a lot of irons that are out there as well, they all have these switches or some kind of detection mechanism. So when it's in the cradle, it shuts itself off. And the idea is by the time you pick it up and you have it in your hand, it's pretty much hot again.
It's an instant heat up. Yeah.
And the cartridge thing, that was another thing that, again, I was new to all this stuff.
Mm-hmm.
And the cartridge thing, so people don't know, you buy basically a temperature range instead. So you buy the tip type and then the temperature range. And the temperature range, there's at least with Thermaltronics and Metcal, there's 3 that they have, and Thermaltronics does color bands, and so I do the yellow, which is 750 Fahrenheit or whatever I think 300, 325 maybe for Celsius, and so it's I don't know, it's super simple and I don't know, it's just one of those things that we're
370, Chris. That's 370 degrees
370.
Celsius.
Oh, sorry.
Yep, 370. Which is quite high. Yeah, that's the only issue with the Metcals and this one is that yes, they are fixed temperature tips. So if you want different temperatures, there's no temperature controller. If you want different temperatures, you have to change the tip. That means if you need different types of tips and different types of temperatures, well, you've got to have an array of 20 tips.
Yeah.
Yeah,
and they're 10 to $15 each, so it's not terrible. Right. It's not cheap, but I can already tell just from looking at the one that I've been using as my daily, and it's just going to last so much longer. Because the iron turns off, because it's that instant heat thing, and it's just going to last a lot longer. So I'm real pumped about that.
Oh well, we'll come back in a year and we'll see how it.
Yeah, exactly. I'll be like, these friggin' things,
But because tip design is all a big trade-off, because some manufacturers will target longer life for their tips. Some will target higher performance with their tips, and it's all to do with what type of material they use in the cladding of the tips and how much thermal resistance that adds to the tip. But typically you can't have the best of both worlds. You can't You can't have a long life tip and a really super low resistance efficient tip. It's kind of like, you've got to sort of trade them off. So each manufacturer
pick and choose,
sort of, So yeah, these things just heat up at one temperature, and they use an RF induction system to do it.
Yeah.
Yep. So that's why a lot of people swear by the Metcals. This would work the same way in that they can instantly deliver the heat to the tip. They don't have to heat up an element, which then has to radiate outwards. So kind of like it just heats up the entire tip. It's not really true because it's still inside. It's still going to make its way out. But your Metcal fanboys claim it's better, and I don't doubt it because I've used Metcals. They used to be our standard production iron.
Yeah, right. And I think that's really what they're designed for, right?
Oh, yeah, that's what they're designed for. They're designed for high volume production because we were doing like big cable harnesses and stuff like that, right? So they needed like big, beefy, and the Metcals could actually deliver, like you can get like a 300 watt one or something, like a really crazy sort of wattage.
Yep.
Yeah, and they deliver that heat instantly, and there's no controls on it that the operators can screw up. Like this, and it's just this big one brick. It's a very robust die-cast alloy brick that it's just yeah. So there's one video I was looking at reviews and stuff, and there was one guy, Shane Burrell. He did a good review, but he was actually talking mostly about the handles, and he said he bought like a lot of Metcal power supplies. So like the brick, like you're talking about, he bought like a lot of 20 off a pallet like 10 years ago, and he said they're just, it's easy, right? So like, as long as you can get the consumable parts still, which a lot, these are all still reverse engineered and they're reverse compatible. Oh, these are compatible with Metcal tips. These are irons. That's right. Yeah. Yeah. So if you look on the Amazon page, all of the tips that I have are cross listed with Metcal tips. Oh, wow. And the iron itself, it's the same plug and everything? I think so, yeah. Wow. Okay, so it's a complete clone. Wow, they didn't pull punches, did they? That's right. This is meant for that thing. Yeah, I'm pretty sure. Don't hold me to. I'm still kind of confused about like there's different series. There's like the series. Oh, I think there's same with Metcal. There's all different series. Like there's just countless ones. I just got the one. I just went in and I was like, whatever is most common, just give me that, please. Yeah. Okay. And like you've got the 2000. That sounds like it's the lowest one, whereas they've got the 9000 and the 5000. Well, even within the 2000, there's different series. So like I have the P series, and that's the handle that came with it, I believe. Because then the tips are tied to the handle. It's like I get they've got three different series on the, and they do have a tweezer kit. They do have a tweezer kit. I know. Chris, you don't have to tell me. What are you doing? What are you doing? I know. It's probably on Amazon. Buy it now. I know it's on Amazon, Dave. I'm trying to save money, man. Like, come on, you need those tweezers. You need those tweezers. Don't do that. I will sick my wife after you, man. Yep. Okay. So your one's got a 1 year warranty, and the upmarket 9000 has a 4 year warranty at $400. That's interesting. Right. And the 5000 is a 1 year warranty. And looks like they have a short tip to grip distance as well, just like the Metcals. That's good. For those who don't know, a key in a soldering iron is tip to grip distance. That's one of the keys. Right. You want the shortest distance between your fingers and the joint. If you've got some long shaft thing, maybe a big phallic symbol, good luck, trying to do decent soldering with it, because it's hopeless because your hand is so far back from the point of control. Yeah, it's like a force times lever arm kind of thing, right? Yeah. You have like a little bit of force and it moves the movement. You have a tiny little bit of movement, half a meter back because your tip's half a meter long. That's right. Yeah, right. It's like you can't control the tip of that thing. So you want it as close to your fingers as possible. Well, you can if you hold it like in the those stock photos. Oh, right. Yeah, of course. Yeah. Classic. You'll have to post a photo on Twitter, Chris, of you holding the iron like a stock. Yeah. Yep. Yeah. Oh boy. Anyway, cool. I had no idea. That's why I hadn't heard of them because, I think I have heard of them. But I've never seen it or looked at them. But yeah, I heard about it from past guest Colin O'Flynn. So he's the one. He's a bit of a gearhead as well. Is that on their about page? Are they brazen enough to go? that, oh yeah, we're from Metcow and we do it better.
Oh, I think they, yeah, I think so.
Really? Yeah.
Mm.
Oh,
Metcow?
design and development is undertaken in the US and Australia.
Hey, there you go.
There you go. They've got a sales office in Perth. There you go.
Perth is like, I mean, it's
well,
on the other side, Dave.
Right, it's on the other side of the planet, yeah.
It's basically another country, you know?
Right.
Yeah.
Wow.
But still, that's cool. Yeah, you should give a shot. Yeah,
okay.
Cool.
Yeah, they've got they actually
and their robot is cool too. I had never seen like the soldering robots before, so like they, you know, these are things that exist in production facilities.
Is that okay? I see that now. Yeah, the soldering robots. Yeah.
Yeah. So it's basically like a 3-4 axis CNC machine, and then it can apply joints.
Oh, right.
And
wow,
that's fun. Yeah.
Yep. Soldering
6 axis. Sorry, 6 axis.
6 axis. Yeah. Soldering robot. Oof.
That's probably out of my price range, so that's not for right now. All right, one more thing in the gearhead column, since this is not test equipment acquisition syndrome. This is test equipment creation syndrome. Yes. I showed you a photo of all of my mounting methods. So I've been creating 3D printed mounts for everything's like up off my bench now.
Yep.
Yeah, I'm very excited about this. So I figured out. So the key thing is if you get these little small rig, like they're these clamps.
The cages. For cameras. Yep.
Yeah, right. And I really like them. They work really well with like the wire racks that I have on my bench.
Mm-hmm.
And then the key thing, I forget what video I wish I could remember what video I was watching. But if you're doing a 3D print, and most things are like PLA, if you make a 6mm hole, you can just take a 1/4-20. So the 1/4-20 is the type of screw that's on the bottom of like camera mounts and tripods and these little things. So like tons and tons of like interoperable gear that's out there, like these little clamps. You make a 6mm hole, and you can just screw that 1/4-20, and the threads are big enough that it grips like crazy.
It grips, and right, straight into the plastic.
I've made a microscope mount. So I got the microscope, the long throw microscope that Voltlog Florin had recommended on his YouTube channel, and I really like that. That's like $100, and now I've got like this great mount for it because it doesn't come with a mount. It's meant to hook on, so it has like a long lens, but it also hooks onto a trinocular stereo microscope.
Right.
And so I now use that. So I made a mount that's rock solid now. I've made a mount for just like tools. So it's just like literally just a bunch of holes in a piece of plastic so I can put my tools in all sized. It all came from the fact that I have the sticky flux that Lewis recommends, and that was getting everywhere. So I wanted to get that up off the bench. And then the last thing is the one that's most relevant in here is that I figured out a way to make a mounting point for my 121 GW multimeter.
I saw that. Yep.
And that thing is great off the bench. It's like, so one piece of constructive criticism is that the viewing angle is actually kind of rough on, I'm sure you know.
You've got to view it's designed to view either straight on or at a lower angle. Yeah, it's not good at a higher angle. There's a lot of LCDs like that, unfortunately. And
so this basically gets it up at eye level now, and it's perfect. So it's like literally perfect to just get it up off the bench. Not to mention it's not like on the angle anymore, and it's like so I can link in my my little STL file.
Yeah, I was just thinking this the other day. I was going to go dig out like an old bench, cheap bench meter from my storage bunker and try and like modify that to be, I think it is battery power, but I was going to like chock it full of batteries, and I reckon I can get like 10 years battery life from like a bench meter. I was thinking, will bench meters make a comeback? Because like a lot of people are like, but I hate ones that are mains powered. Like, I just don't want another thing on my damn bench that's mains powered.
Yeah,
I've already got 50 things on there, right?
Yeah, and it really starts to eat up your space. So I've been working on this really big PCB, and like it's just like cables everywhere. And so first and foremost, I just want to get cables out of the way, and then also just reclaim the actual space. So like if I'm using like a low slung board, or if I'm using those PC Bytes, or even like my Panavice, like to hold this huge board, it's just like it's just like I'm bumbling everything. Everything was just falling off the bench nonstop. And now it's at least up. And so like tools are up, the DMM's up, the microscope's up, and it's still, there's still a ton of cables, but it works a lot better.
Yep.
So Yeah.
Sometimes I wish like Fluke still sold their Fluke 37. Have you seen the Fluke 37?
I don't think so. No, I'll look it
Okay,
up.
here we go. Hang on, I'll get you a photo.
So it's a bench. So when you say bench meter, though, how do you define that?
Well, one that's like a flat, like it.
Oh, this is the one like Dave made. This is the
Huh?
Dave. I forget his last name. He was on the show.
He made a Fluke 37. What?
Yeah, he designed it. Remember? No, you don't remember?
No,
this?
no,
Dave
no.
Taylor.
No. Dave Taylor. No, he did the 8060. He did the famous 8060. I don't think he did the 37.
Oh, it looks very similar. Sorry, yeah, you're right. That looks very similar. I thought it was. I'm looking at a picture of a Fluke. What I'm seeing on the internet is a Fluke 37. It looks very similar with the push buttons on the side. So
No,
okay.
no. You're looking Fluke 37. Are you sure you're searching the right thing? You do Fluke 37. Google image search. It looks like it's got like a carry handle on the side.
Oh no, the first picture is at 8060. You're right. Okay.
It's
Yeah,
like
my bad.
it's
Okay.
like a combo. It's a kind of a weird combo bench and carry meter. It's got like a case on
Ah, it
top where
looks
you
like
can
a
put your
flashlight.
leads inside. You know,
Yeah. Okay.
but it's
Yep,
but
I
it's
see it now.
got but it's battery powered and it'll last 1,000 hours with a 1,000 hours from batteries, right? And
Yeah,
and it
it's like a
just
9 volt,
and it
yep.
can sit on your bench and it's just perfect. It does just what you want. I
Yeah.
kind of wish
Yeah,
there
you
was
should totally
know,
bring these back, man. You
Yeah,
should bring
I
them back. You
know.
know what else you should do? Retractable leads. That's what I need. I need a
retractable lead.
Man, I
retractable
tell you,
leads.
that stuff would sell. I would
Patent
buy
pending.
retractable leads in a minute. I don't know if it would impact like the installation and like the
You
characteristics
would
of it.
have to anchor it to your bench though, unfortunately, because the force of pulling the leads out. Sorry, my mind instantly went to the practicalities.
No.
Of
So
actually-
that's great. It doesn't have to be attached to the bench even. These could be a completely separate product. I want to see like a you know how they put like car cables, like jumper cables. Sometimes they're like in like a thing that can roll up the leads or the cables
like a
themselves.
vacuum cleaner. Vacuum cleaners have
sorta, yeah.
retractable power cords.
Oh yeah, no, that's a great example. Yeah, that's right. Yeah, for the power cords. I was thinking
Right.
the tube.
Yeah.
Yeah,
You want
yeah,
a
that kind of thing. And it's
retractable
got like
test
a
lead.
yeah. I totally want that. And they have that for power leads as well, right? So like for extension cords,
Yes,
they
they
also
do.
have for,
Extension
like
cords
rigging.
and stuff. Yeah,
Yeah.
they have a
Yeah.
windy wheel kind of thing, but they're
Mhm.
usually
Yeah.
manual. You know, they're usually not sprung, loaded, or whatever. The
Mm-hmm.
advantage is that test equipment leads, they're already inherently highly flexible because if you get the proper silicone leads, right,
Mhm,
they've got
yep.
like 256 strands in them, right?
Yeah,
They're
right,
they're
right.
highly flexible, and
Right.
that would actually lend itself to a windy mechanism.
There you go, man.
Yeah.
Go make that product. I'll buy at least 5
Yeah.
sets.
Hmm.
Because that's the thing. I
Anyway.
just have cables everywhere, and I just love getting. This is like my thing for moving too. Like the first
Mm.
thing you do when you move, set up shelves, get everything off the floor. There's nothing more
Yep.
frustrating than like tripping around boxes when you're moving. That is
Yep.
just like that is
Yep.
the number one way that I will get into a rage or when I'm moving.
Yeah,
stuff,
nerd,
You know,
nerd rage.
yeah,
Yep.
nerd rage. Yeah, exactly.
Yeah.
Yeah, it's terrible. So
There you go. So anyway,
all right. I'll take 10%. Only 10%.
okay, 10%.
Yeah,
Sure,
10%.
I will. After this, I'll do a poll on Twitter. Should we bring back the bench? Should we bring back the Fluke 37?
Yeah, that doesn't look like it has a lot of digits.
So what do you
Am
need
I-
digits for, dude?
I don't know.
Three and
like,
a half digit, good enough for
3.5.
Australia.
Okay,
Come
all
on.
right, 3.5. Yeah, okay. I'll take 3.5.
Jeez,
That's fine. Yeah,
But, hey, well, these days you do like 6,000 count.
yeah.
Yeah, no, you would make it 60.
I think what you should do, you should just start selling these mount things with your 121 GW. Just sell that as a stand.
Right.
Like this is really a decent solution. Just to get it off. Just getting stuff off the bench is the main thing.
Yep.
So, yeah. You're welcome. 10%. That's all I ask.
Well, I can buy a magnetic hanger for it. There are, a significant number of people
Mhm.
ask for the magnetic hanger.
What's
so I
magnetic? Because like to insert in the back, you mean?
should- Yeah, you can insert it in the back. Yeah.
Oh, cool.
So
Okay.
so then
Yeah, great.
so then you can if your bench is metal, well, I've got half metal, half wood. So I can
Yeah,
if I put a metal bench, I can just stick it onto the metal bench.
Yeah.
So it just sticks there because those things are super strong. So it holds the weight of the
Yeah,
meter,
right.
and it's just
Cool. Yeah, that works too.
So,
That works too.
I feel it.
I think I'm out
It's
of new
time.
gear. I think I'm out. So
Well, you don't have a. Well, no, you've got a bench meter, haven't you? Surely you've got like a Keithley.
I've got a Keithley 2000.
Yep.
And I just was sent a Analog Discovery Pro 3450, so I'm going to be trying that out too. So
what's a
that's on the list
3450?
as well.
Is that the new Pro one?
Yeah, it's the Pro. Yep.
Oh, with like in a case and everything with like BNCs.
Yeah. It's definitely a different style. It's closer to like the NI, like
yeah,
what's that
it's like an
bench thingy?
NI. I've got an NI on my bench at the moment, but that's like super duper high end, you know.
Yeah, and so it's like so Digilent is NI now, so I'm sure that they're very careful about to do that. And Caitlin was very nice to send me one. I'm going to try it out. I love my Analog Discovery too. Like I love it.
Oh yeah, it's great. Yeah,
well, specifically because it's portable.
It's the
so
software that makes it.
Yeah,
it is the software that makes it good.
Yeah. Well, and the portability. I have to focus on that.
Oh, totally. If you need to move it somewhere, you know, if you need to go to the client site or something, you just have your laptop and of course, you know.
Yeah, and it's got like scripting and all that other stuff. So I'll see how this goes. You can tell that this is like a thing where they had people using them in production. I'm pretty sure that this is like the big brother. You know, they're like, hey, make it more legit, get some better specs, that kind of thing. It runs Linux on it.
How much is it?
They have not
it runs
yet.
Linux on it. It runs.
Yeah,
Linux
you can do like
on
you can do like a local mode where it has a Linux computer internally. So again, I
really?
just got the box.
They've gone to town because the old one just had an FPGA with an internal ARM core in it or something.
Yeah, it was like it was streaming mode, effectively.
Right. Oh yeah, it was just streaming. Okay. Yeah. Right. Okay. Interesting. So how much is this? Because the Analog Discovery is not cheap, unfortunately. Like if you buy it retail price, not like student price.
Yeah, retail price is like $350 for the Discovery 2, Analog Discovery 2.
Yeah. So this thing's got to be over $500. I'd be surprised if this thing's under 500.
Sure. Yeah, I'm pretty sure. Because also, I think because they're targeting production, and this is
of course. Oh no, this is it's got Pro in the name, right?
That's right. You got to pay extra for that.
Yeah. Oh, right. There's no price on it yet by the looks of it on their webpage. Yeah. So I don't think. Yeah, but I'd be stunned if that's under $500.
Mm-hmm.
Yep. Wow.
Oh, there's the Analog Discovery 2 Pro bundle, but then there's also the Analog Discovery Pro. That's
okay.
That's confusing, but though, that's.
What does the Pro bundle come with?
That's just like the Discovery 2 with like cables and stuff like that. It's got all the bits and bobs that come with it. This is different. So. Yeah.
Geez, it's got 4 USB ports on the back.
Mm-hmm. Yeah.
Wow. What do you need 4 USB ports for? Oh, a keyboard and mouse or something. Can you hook it up to like a monitor? Is there like local, like if it's Linux inside, can it be?
No, I don't think it can do any of that stuff. I think again, I have to still check it out, but
no, it doesn't have any sort of USB-C video out or anything. So no.
So it says Linux mode provides an on-device operating system that when combined with Waveforms SDK is a flexible jumping off point for all kinds of tests and applications. So I think the idea is that it kind of like you program it and it's just like a standalone running thing, I think.
Oh yeah, this is you could
like if you're making a test stand, you want it, you don't you either put a computer in there, you buy an Intel NUC or you do something like this.
That's right. Oh yeah, I know. I could totally see these being used in production test rigs. Yeah. That was my business. That was my business for over a decade.
Exactly.
And this would have been killer, you know. Whereas before we needed like 19-inch racks of everything, it's like, and so you end up with this gigantic rack on a trolley because, you just had to buy off the shelf 19-inch rack computer. Right. You had to buy it off the shelf, It's like everything had to be 19-inch rack. And it's like, oh God, enormous, right?
Yep.
So very nice. Very nice. I think that's going to be very popular. But for me, the thing that makes it is the software. The software is very comprehensive.
Yeah.
It'd be nice if it was open. Like the script inside of it is open, but the software and hardware aren't open source for this thing. So it's, it's a closed design, which
I don't
is
really
fine.
expect that on test
I got
equipment,
no problems with that.
Yeah.
It does the job. No, the software is really good. The software is very comprehensive. So very impressed.
I will say a little callback. Clint Cole, former president, now retired. I think he's doing educational stuff, but he was on the show some amount of time ago. I'll link it in below. But Clint was a fun person to talk to. So
cool. All right. We have to get to it. We have to get to the big.
We do. Yeah.
Electronics.
This is big news. I think. Yeah. Although by the time this comes out, people are like, yeah, we know, guys.
yeah, we know. Okay.
Yeah.
There's a new Raspberry Pi in town, and it's not an ARM Micro based thing. It's their new processor.
Well, it is an ARM Micro. It is not a Linux.
Oh, sorry. Yes, it's a
ARM
Cortex
Micro.
Zero, but it's a microcontroller. It's a It's a microcontroller. It's called the RP2040 is the chip, which Raspberry Pi they've actually developed this chip. They're not using an off-the-shelf chip. It's
Custom
they've developed
silicon.
their own micro. Yep.
Yeah.
And and it's a microcontroller. It's not targeted at the high-end Raspberry Pi. It's targeted at the really low, cheap end. And so it's the RP2040, and the board that it's on is called the Raspberry Pi Pico. Yeah. And one of my most popular tweets in a long time was that I tweeted out a photo that it comes on a reel. The board, the
board comes
castellated board. Yeah, haven't you seen this?
Oh no!
Oh,
sorry.
dude.
That's pretty cool. I wonder if that's just because like it should be. They expect it to be integrated with the castellated edges.
They expect it to be integrated with the. Yep. Here we go. I will copy image address. Here we go. There you go. Look at this. Look at this bad boy. Oh, come on. It's not going to paste. Can't I paste the URL? Image address. Copy image address. Thank you. Bloody computers. Hey, computers. There you go. Look at that. Look at that bad boy.
That's pretty cool. That's a
so
wide tape. That's a wide tape it's on.
They were thinking about that because tapes are a standard width, right? They come in various standard widths. So they would have designed that board. They would have had the foresight to go, right, we want this on a reel. And, let's make the board to match the width of, the biggest reel we could get or whatever, this certain size reel. And they've made the board to match. So the entire Raspberry Pi board comes on a pick and place reel, which is, fantastic. I think it's only like 0.8 millimeter board or even less. It's like a very thin little board. And it's got the castellated edges, just like all the other modules on the, little micro modules on the market. Name them. There's like hundreds of them.
And they're cheap, man. This is, I think that's probably the biggest thing is just that it's real cheap.
It's cheap. This is like... Unfortunately, it's not going to be that cheap in volume because the Raspberry Pi, you get it cheap if you buy one or two of, because it's an educational thing. But if you want to buy 10,000 of these for a production run, you can't get that price, I believe.
Buy the board or buy the chip?
Buy the board. The price goes up. This is the only thing in this industry where the price goes up with volume. Because Raspberry Pi, if you want to buy, they do this with the compute module, right? If you want to buy the Raspberry Pi, plug-in compute module, it's if you want volume, if you want industrial type volume, the price goes up. Whereas if you can buy,
it starts up actually. It starts up. It doesn't actually scale up. It's not like you buy 1,000 and
no, but it goes up. It's cheaper to buy it one off on Adafruit. It does. It goes up in price.
I'm just saying, if you buy from Newark like I did, and you wait 6 weeks like I did.
No. The Raspberry Pi, they are low cost at Adafruit and other sellers because they only sell one or two. They limit your quantity. You can't go to Adafruit and go you can't order 1,000 boards of these through Adafruit. I don't believe so. Maybe this one's different, but the other Raspberry Pi ones, the other Raspberry Pi products, the price goes up. I've looked into this. I've looked into designing a Raspberry Pi cluster, right? And the price actually goes up with volume. Yeah. They specifically say it on their website. And the dealer websites, they go, this one or two price is cheap because it's educational pricing. If you want more, you pay more. It's backwards, but that's the way it is. Right.
I'm just saying that, yes, that is the cheap price, but once you get to the first quoted one, it's not going to go more. It is going to be like, so, okay, you're going to buy one from Adafruit. Great.
Yep.
You're going to buy one out of distribution or one out of, you're going to get quoted for one, and it's going to be a much higher amount, but it's not going to go up from there then. Like that's where the disconnect is. There is a step function. Yeah,
there is a step function. Yeah, that's right.
And then it will go down from there. So
and then it will go down. Yes, that's right. Yeah. So, yep.
Okay, I think we're on the same page now. Yeah.
Yes, we are.
Huh. Yeah.
Oh boy.
Well, so what do you think of this thing? I mean, I don't know how much you've looked at the data sheet and everything. It's pretty pretty great documentation from what I looked at so far.
Yeah, it's got external flash, doesn't it? Oh, sorry, what's external. Yes, it's got external flash. Does it had external something?
It's got flash on board. It's got SRAM on board. It's got RAM, I think.
There was something it didn't have on board because that would have increased the cost.
Okay, I don't know about that.
Tube Time on Twitter, he did this huge Twitter thread about it.
Yeah.
About the costing of why they didn't include, because they would have needed extra masking on to include this function. So I'll try and find it.
Yeah, you put that on the list actually. So why are chips so often expensive?
Did I?
So yeah.
Ah, yes, I did. There you go.
Yeah, good job, Past Dave.
Yep. I'd forgotten. It's been so long.
So it's very interesting. I think that probably the thing I hear about most is the PIO function, which is the programmable IO. And basically there's like a assembly language to go and program the, like small arithmetic style interfacing to these chips. So it's basically like not quite like an FPGA, but basically it's like there's a way to handle combinatorial elements of different pins and then alert the processor to the output of that. And so that's a little bit different. And I think something that's going to be interesting in this case. I was talking to Mike Stish about that today a little bit. And the fact that it's just like programmable, it's, you can like offload. So if you were imagining, you're taking the input from pin 1 and you're trying to add it to the input of pin 2, you, in theory, as a very, very simple and maybe wrong example, you could basically combine those two and then have the output without having to use the cycles internally on the dual core 133 megahertz Cortex M0 that's actually running. So you're not hitting the actual core of the micro. You're doing this kind of stuff outside the function, outside of that central processing block. So kind of interesting. I think there's going to have to be a bunch of code written for it still, or some people dig into it. I think schlubs like you and me are not going to go and do that.
Right. No, yeah. I was right. There is no internal flash. This chip, the micro itself, does not have internal flash. It's got 264K of on-chip SRAM, but it has support for up to 16 meg of off-chip flash memory via a QSPI bus. And once again, Tube Time in his Twitter thread. Here's some people. I'll point this. Here we go. I'll send you the exact thread so we can link it in so that you can have it. Yeah, he explains why the flash is external because of the masking cost. To get the flash internal to the micro, it would have required extra masking steps, and to get the price point down on this, they wanted to have they wanted to get the actual chip itself, not the entire module, but the actual chip itself as low cost as possible. So they left out flash. So it has no internal flash memory, which is going back, which doesn't make it.
Yeah, I mean, flash is like super cheap anyways. I mean, like that's the other thing.
It is, right? And that's the point, right? But technically, this is not a microcontroller. This is a microprocessor. It is not. I'm gonna tweet this after this. Yes. I'm gonna put it up with the meme there. Change my mind. The change my mind meme with the sitting there. No, the Raspberry Pi is a microcontroller.
But back when microprocessors were microprocessors, they were not using flash, right?
No, they didn't have anything.
I thought that's also the RAM bus though too, like having access to like the memory bus in general. So like for like RAM. Isn't that the other distinction? Like the memory bus is external.
No. Well, all external memory. No, all micros have some form of internal SRAM. They've got some form of internal, be they just register memory or something. They've got at least something there, right? Whereas, the traditional definition of microcontroller versus microprocessor is that it has all the memory internal on a micro, all of it. That means program and data. And data memory. This only has data memory internal. So I'm claiming this is a microprocessor. Prove me wrong.
I always thought it was like having the actual like memory bus exposed, like having at least 8 pins, 16 pins, 32 pins. But
technically, no, it's No.
That's just how I've seen it. I'm not saying that that's the actual definition, but like, you know, like because that's what a lot of the traditional microprocessors were.
No, the definition of microcontroller is that you can program it and it executes with no external chips.
Okay.
No external. It doesn't matter whether it's bus or it's an SPI like this one. Makes no difference. All the functional, you can run the program internal to the chip. You can't do it on this. It is not a microcontroller. Damn it! I'm going to die on that hill.
Worth it, I guess.
It's a microprocessor. Damn it.
Yeah. Well, here's some news. I guess you can. I will put the screws to three of the Raspberry Pi team next week when they are on the show. So
great, do it. Tell them Dave said.
Let me tell you what Dave says about this, and they'll be like, okay, so what?
So what? They're just going to go. So what? We called it a microcontroller. Sue us. And,
right.
Fine.
Right. Okay.
My lawyers will talk to your lawyers.
That's right. I'm going to take down an education startup. They're into educating people. I'm about being right.
Yeah, exactly.
Oh boy.
Somebody's wrong on the internet, you know.
Right.
XKCD.
I'm curious about like why they did it. It's very interesting. I do like that they're
I know.
Sharing
Everyone's saying the same thing. Like why? Yeah. And it's not open. Like this is not, you know, and I was sure it's got
this to be either, you know, like
no, it's expensive,
right? I mean, this is an expensive thing to do, right? We've had people on the show talking about Brian was just on the show talking about FPGA stuff a couple weeks ago. We've had Tim talking about all the Open PDK stuff. Sorry, Tim Ansel, Brian Faith, right? So like thinking about all that stuff, it is still very expensive. I was just talking to Mohammed Qassem, who's been on the show as well, and it's just like it's expensive to do this stuff.
Yeah, it is. But this thought just jumped into my mind because they're an educational foundation, technically not for profit, right? Mm-hmm. Technically, I think. I don't know. It's been a long time since I've looked at the Raspberry Pi Foundation.
Yeah. I don't know how UK. I don't
I don't. Yeah, under UK, but I believe they're like a foundation, right? They're a and some sort of educational foundation.
Yeah, they are. Yep, that's right.
Does that mean that they get any like tax breaks, tax subsidies for doing something like this? Is it potentially cheaper for them than it would be for some other manufacturer to do it? I think that's a worthwhile question.
Well, when you look at how that stuff works, I mean, even in as far as I understand the ones in the US, it's like they can retain earnings, but they can't pay out earnings, right? So that's like the big thing. So like for 501c3. Right. But in the case of expenses...
Okay, it is a UK-based charity. Yep, the Raspberry Pi is a UK-based charity. Yep.
But in the case of like on the business side, it's expenses are still expenses, right? So if you're
of course.
Profitable business and you spend $1 million on mask sets and you make $2 million in the year, you're still only taxed on that 100, that other million that's left over, right?
Yes, exactly.
And so I think of course. The big thing is that they just, they don't take that profit. They don't get taxed on that profit because they're, I'm way out of my depth there. But the expense side, I don't think would matter.
I think that's a reasonable question is that, why would you do this and put all the expense of designing your own microcontroller when there's already thousands of them out there to choose from? Like literally.
I wouldn't say thousands. I mean, there's thousands of SKUs, but there's not thousands of companies.
Right. No, and so I think, but there's dozens, right? Okay, there's dozens.
If I had to put a guess forward, I would think that they looked at the economics of it all, and it's just cheaper. Like at the scale that they're working at, like they just.
Oh yeah, they wanted to sell it cheap. Yeah. Yes, exactly. I'm sure that's the answer. Yeah.
And so the thing that I mentioned on Twitter, I think, but it was like. I remember being skeptical on this show, and we were very skeptical of Raspberry Pi when they first announced it. We were just like, how the hell are they going to do this, right? I mean, it's just like the cost basis and everything.
Yeah, it was so cheap. No, it was under the cost of what you could buy the chips for.
Yeah, well, commercially, yeah.
Or something like that, yeah.
And they have delivered over and over again. I mean, they just, and the fact that they're educational foundation and all this other, like, I'm very glad they're around, and all of the similar kind of companies that are doing this stuff. And so I think though the one thing that they have that other ones don't is just the scale. Like I don't know there's no other companies out there that are doing this kind of educational hardware at the scale that they're doing. And the basis for all of it is the fact that a lot of people thought they were going to use it for a media center or are using it for a media center, but bought it and it sits in a drawer. But they still paid
Yeah.
that $35 to
Exactly.
subsidize the people that are using them, and like, man, that has an impact. What I'm curious about is if they're going to be able to hit the same numbers for this thing. You know, like what is the break even point? You know,
for with this micro, because technically it's a new target market.
Yeah.
Right? It's a new target market because this doesn't, it's just a board with I/O pins on it. It doesn't hook up to your HDMI monitor. It doesn't hook up to your keyboard. You know, it's like, it's a very different target market.
It does hook into a keyboard or into those things. It can be a tiny, like a 80s, 90s era.
Oh,
computer.
can it? It uses it uses the USB-C thing, does it?
No, I think it's USB. I think it's USB Micro B. But it can clock and drive a VGA at least. So if you overclock it, there's...
Yeah, but you can't do VGA over USB.
No, I think they're big banging the pins, I think. So I've seen it. I've seen it driving. I've seen it driving a monitor at least once. I forget where it is.
Right. Okay, but it's not. But it's not the same though. It's not the...
I mean, these... Well, anyways, we'll hear about it next week. I'm very curious about it all because I think the one thing that's very exciting about this specifically is like, okay, $4 circuit board. If you can plug in, if you can plug in a, you know, keyboard, mouse, whatever, and you can drive it to a monitor, then they've just 1/7 the price, maybe, or more than that, probably 1/8 the price of a Raspberry Pi, which sounds like, oh, well, $35 versus $7 or $4 rather. Like that's, you know, crazy cheaper.
Oh, but there's a big drop in functionality. I mean,
sure, but the real thing is, if it's a truly an educational thing, just getting this thing out in the world, you know, like, I look fantastic. At like the costs of technology, even Raspberry Pis, it's too expensive for certain classrooms. You know, they got to share computers, whatever. Like, and if they start to disseminate it more, then that's amazing. You know, if there's just more people.
But I'm going to say, but Arduino clones are this cheap as well.
Yeah, but maybe not the same functionality.
You can get one for $5 delivered. Yeah, have they not got the same? This one's probably more powerful. Yes.
Oh, way more powerful. Yeah, I mean.
Yep.
Dual core 133 megahertz.
Well, I don't know. I haven't done that. Oh yeah, because it runs it like it's got 264K of SRAM for starters. I don't know how much flash memory. How much flash memory does it have? And it's actually clocked at 133 meg. So I don't know if there's any Arduino clones that come close.
Yeah, and I think I was watching Limor and Phil talking about it. So they also sold them to, like, Adafruit has some chips and SparkFun has them, and they basically are other companies, other open source hardware companies are building with them as well, which is interesting. And so I think I was watching.
Oh, so you can buy the individual chip now?
You and I cannot,
for sale yet?
But they are going to they're going to do that, I think.
Right. Okay.
But Limor and Phil were talking about...
Oh, you'd be mad not to.
They were talking about, like, the actual overclocking, I think. I'll try and link in that video as well. They did, like, I think Lady Ada's desk. And yeah, I mean, like, they're just talking about the capabilities of it all. And if it is capable to be a simple, small computer, like, it's not going to be a smartphone, whatever, but it's like, if it is at that same level and this might drag more people down into the embedded kind of world too. And, like,
that's what I was about to add. Yeah. Yes, exactly. Yeah. Whereas the Raspberry Pi is like, there's a lot of people out there complain, oh, that's not really electronics. You know, if you buy a Raspberry Pi and you just run Linux on it, that's not, you know, whereas this, you do actually have to get your hands dirty, so to speak.
Yeah.
You know, yeah.
Yeah. And
yes, you are dragged down.
Level. Yeah. I think some people are going to be unwillingly, right? They're not going to be super happy about it. And that's okay. Right. Like, I think a lot of people are going to get these and be like, oh, wait, I have to do what? Mm-hmm. But this is going to be a whole new generation of people that are doing interesting things at low levels and low power. So very exciting.
Can I tip my hat very briefly to a small thing that I noticed? It's on the PCB layout side of things. So whoever laid out this PCB, slight tip of the hat. If you have a look at the pinout of this thing, right? If you get the or even the photo of the board, all of the ground pins, there's 2, 4, 6, 8 ground pins on this thing.
Yep.
They have square ends on them.
Yeah, that's a nice little touch.
Whereas all the others are rounded. Yep. Nice little touch. Very nice. Yep. Very nice. Somebody was thinking. That's yep. Very impressed with that. So would have been nice if they could have squeezed the silk screen on the board. though, you know, to tell you which. Look, I just see all that.
It's always
space
something,
being
man.
wasted.
It's always something.
I know. I just see all those all that space, all that potential silkscreen space being wasted, you know. Yep.
Yeah, but
Can't help
then you don't go read the docs, you know? Like
right. No, yeah. Okay. Well, you know.
let's take a sharp right turn into the past here. This is a cool little project I found on Hacker News earlier, Tejotron. Did you see this thing?
No.
So basically it was inspired by Ben Eater's tutorials. So Ben Eater's been on the show before. He does the 6502 computer on a breadboard. It's like a whole course. Cool. You can buy stuff from him now. Really, really fun.
Oh, nice. Really?
Yeah, so he sells kits now, and basically you can follow along and do everything. It's great.
Right.
Someone took that, and then they put it onto the site, tejotron.com, and then it's got like virtual representations of the chips, and then you can run assembly in a split screen and see what happens. It's super cool. So you can actually like step through.
Where's the link for this thing? Is it in our...
Yeah, I'll send it to you right now.
Not finding it.
And so you can step through and actually see it executing different things. You can watch the ROM, you can watch the RAM, you can watch the CPU instructions, like all the registers in there. And it's just like, you know, like so Ben's course is awesome. But this is like basically now peeking inside of it as well. Yeah.
So the website is instantly, you don't have to, I like that you just go to the website, tejotron.com, and you're instantly in the editor, are you?
It's a Hello World like program's already written on the right side, yeah.
Yeah. And if I press play.
Okay, so this is where it gets tricky. I kept clicking play, and I was like, "What is going on? What is going on?" Click the thing to the left of it first. It's like a rewind button first. Click that first.
Oh, really? Oh, no!
And then click play.
There it is. Oh.
Isn't that cool?
Oh, that's beautiful.
Yeah. So super fun, super fun thing, and like a great way, you know, like I don't do assembly, you know, like, but this is I think a lot of people like that about Ben's course too, and more generally just working with old school processors, right? And like being able to see, probe the memory bus, probe the pins that are on there, and and now there's a thing.
The problem is encouraging people to do this. I mean, these are two opposite extremes. We just went from this, you know, newfangled Raspberry Pi Micro that's you know going to have all this high level joy and wonder to it, right? You never have to really go beyond, I need to hook something up to this pin to make my LED flash or whatever. And then you've got the opposite end of this gorgeous thing of, you know, being able to single step through instructions and watch the pins toggle live and the registers go and the RAM and the ROM and there's the CPU registers going, the address and the data and the program counter and all the registers and stuff like it. That's just, like, you got it. Like,
what's the downside here, Dave?
It's got to be a limited market. I mean, it's like, how do you entice people to get that low level?
Oh, yeah, I think you don't. I think. Okay, here's the thing. Here's the thing that I think.
There's always going to be a certain percentage.
Dave, let me talk to you as a electronics educator to electronics educator. People are coming in at all different spots, you know, like I just feel like you can't predict it, you know, like there is no one way in. No. And I feel like having all of these different things, like some people are going to come in from the Raspberry Pi world and be like, oh, RP2040. I wonder if I can, you know, use this as a media center. What? I can't? Oh my God. And then they're going to go figure it out. And then they'll be like, oh, what is a resistor? You know, and it's like, that's great. And some people are going to come in and, you know, they're coming from the ham radio world and they've used, you know, they've built up small QRP things and they're like, oh, I can automate this using a RP2040. Like, that's great. You know, and it's just like, who cares? There's all these tools now. So
yeah, of course.
Find your bliss, people. Find your bliss. Tell other people about it. That's what electronics is about. Yeah. But this is beautiful. It's beautiful. Really nicely done.
Sex on a stick. Yeah, this is very nice.
I couldn't figure out who did it. You can buy them a coffee, but you can't. There's no.
Oh, really? You don't know who's done this? Oh, yeah. There's no like about or anything.
Tejotron is the person. So yeah.
Wow.
Some people like their anonymity.
You can no, there isn't about. No, Tejotron. Yeah, you're right. You can buy. It's inspired by Ben Eater. Okay, but they're anonymous. I'm sure it's on their resume somewhere. So I'm sure, you know, somebody might.
You go stalk them. I'll do other stuff.
Boy, that's just that's impressive. Anyway. Wow.
Yeah.
All right. What else? We got our shows up, but do we have anything else pressing that needs to be done?
Let's go way up the stack. So Beagle, beagleboard.org, and Seed Studio, and I forget their Sci5.
Does anyone use Beagle boards anymore?
Yeah, I do.
Yeah, it's still a thing. Okay.
So I think the thing is the AM358, whatever the hell the processor number is, it's getting long in the tooth, right? I mean, like so I was doing a project with a software person, and we were like, oh, okay, let's like compare. Like, could we use? I like the thing I like about the Beagle board, the Beagle Bone, which is the Beagle Bone Black, is the board that's the shape of a Altoids tin. It's got the double rows of pins, whatever.
Yep.
I like the same kind of thing that they have a similar thing as like what they have on the new Raspberry Pi thing, like this low level handling of pins, right? So on the RP2040, it's this PIO, so that you can like interface with the IO at the device. On the Beagle board, on the AM3358 or whatever it is, they have the I forgot the name of it. RSU? No, that's not it. The PRU, that's it. So the PRU is the programmable real-time unit. And so when Jason and Robert were on the show from BeagleBoard, they talked about it a bunch. But basically, it's like you could program it to just sit there and monitor for a certain bit pattern, and it's just sitting there spinning, just waiting for this bit pattern, and that's all it's doing. There's like actually a separate core in there doing that. That's cool. I mean, it's like great for low-level embedded control while you also still have like a high-level Linux computer.
Yeah, of course. Yep.
So that's great. But it's just the computer itself is getting a little old. And so they've got new things out there. And one of the newer things is, so they had come up with this thing called the Beagle AI, I think is something like that. Basically, it's like meant to do like vision processing. And now this is a new one, but it's using RISC-V. And so like that's super exciting. So it's Star5, Seed Studio, and beagleboard.org. And basically it's this new processor. It's all open source hardware, open source software,
Sweet.
RISC-V. So like, and it's like actually modern, like capable of doing like high level vision processing with all open silicon too, which is like really cool. I don't know if it's, well, I don't know. Actually, I don't know how open the silicon is, but it is
right. Well, okay.
RISC-V, so an open ISA at the very least.
So technically it's open, but
I don't have enough information about the Sci5.
Yeah, that's interesting. Right. The RISC-V, right? The RISC-V, however you want it. What is
RISC-V.
kind of the?
It's RISC-V.
Yeah, it's RISC-V is the majority pronunciation.
No, it's I've been corrected many times now. Enough times that I'm not saying RISC-V or RISC-V anymore.
Okay, right. Okay, the RISC-V, right? It's an open source core, right?
No.
But
nope.
No, well, no, it's not.
No, it's an open source instruction set. So it's the equivalent of
right.
x86.
It's an open source instruction. Right.
Right.
Okay,
so which is interesting. I don't know if we mentioned on here, but PowerPC, the instruction set is now also open. That was like a response.
Oh,
to
okay.
That.
Yes.
Yeah.
Right.
So that's also open now.
So how does the license flow down? If you take the RISC-V instruction set and you design a core and you sell that core, like say it's a drop-in core for an FPGA or something, do you have to make all of that open as well?
Nope.
No, you don't. Okay, right. So that means somebody can come along, take that, and sell chips, sell proprietary cores, soft cores, and hard chips as well.
That's right. Yep. And that's
right.
So Brian Faith, who was on the show three episodes ago, I believe.
Yep.
Brian Faith is the CEO of an FPGA company, and QuickLogic, and they're doing that. They're selling open source IP, not open source IP. They're selling IP. They're also, they can implement RISC-V cores and similar. So, yeah. And
I think that's the only way it probably would speed the adoption, would help it spread. Because if a lot of companies go, oh, well, do we want to make chips with this open source core? Oh, no, because the license says that we have to then make our chip design that we spent millions of dollars developing open source as well. It's like, no thanks. So I can see a lot of companies doing that.
Yeah, I don't know if that was ever.
Yep.
Yeah, I don't know if that was ever in the plan. So, but the ISA, the thing that I didn't get about the ISA thing is that if you go and compile so again, we were just talking about this Teijotron, right? And it's showing you assembly code, right?
Yep.
And at the end of the day, what that's doing is it's going through the instruction set and it's saying, like a move is this code and a jump is this code and whatever. And basically now there is, a RISC-based ARM instruction set, right? And now there's the RISC-V based instruction set. So the compiler is similar and like it can tell that the instructions are the same. And so you could start to target multiple pieces of silicon. I was really confused that you could just switch a flag in GCC and it starts targeting RISC-V stuff. Like that is just so crazy to me. Yeah. But that's a thing, and like, I don't think it's like perfect. It's not flawless, but it just seemed like it came out of nowhere. And the answer is because GCC then pulled all the RISC-V instruction set in, and then they basically tested the compilation down to these instructions. And that's because, and basically it's because there is this new instruction set there too. If there was a similar compiler, if GCC supported OpenPower or whatever the PowerPC one is called now as well, you could go and switch over to that. And it's literally just it's like a flag difference. It's nuts. I mean, like it's like really like switchable architecture at that point. And there's a ton of things happening under the hood, of course, that I have no idea about, but like it just feels like it felt so sudden to me. And I know it was not. There's a lot of hard work that went into it, but it's just, that's where the rubber hits the road for me. Just that.
Yep.
Yeah.
Sweet.
Yeah. So, and we should say like that. Now you go way back up the stack, and so Star 5 is the name of the chip that's made by SiFive, and it's using the open source instruction set, but it's also at like the level of like, so this is like a dual core U74 1.5 gigahertz. Like this thing is just like some crazy amounts of silicon in there. And it's got like a DSP open or computer vision like coprocessor in there too, right? And basically, the thing that's going to be interesting about all this stuff is that people are making cores using this open source instruction set. Some are open, some are closed. I think a lot of the biggest ones are going to be closed probably, but it's still like it's spreading adoption a lot more, and that's very, very interesting. So we'll see what happens.
Cool bananas.
Yeah.
Yep. All right. That's our amp hour up.
Yeah, I know. We don't even have time to mention there's General Motors just announced they're not going to make gasoline cars anymore. Like, all right, whatever.
Yeah, I wouldn't be surprised if that changed. I wouldn't take that to the bank.
I mean, I wouldn't take it to the bank either, but like, I don't know. There's lots of other links. Yeah. That's the thing when we don't do a show for 3 weeks, it's just like there's other links. So go check out the links.
Yes.
We'll put a link in the show notes.
This year's going to be huge for EVs, but
Yep.
I wouldn't count your chickens.
Okay. No chicken counting here.
Excellent. All right. Catch you next time.
While we don't count our chickens on the Amp Hour, we do count on our patrons who are helping to bring this and future electric episodes of the Amp Hour into the world in the coming years. You can join the Gearheads and Thermal Grease Monkeys at patreon.com/theamphour. Come and join in the group therapy session and work out your test equipment acquisition syndrome issues in a safe Discord space.